Welcome to this introductory web lecture about usability principles. In part 2 of the course, we discussed design principles. They state how you should design a control or its feedback in order to make an interface usable. Usability principles are more about the state a system should have, and several of the usability principles deal with a whole process of performing a task and making sure that the whole process is a smooth experience. We are mainly considered in usability of automated systems, although some of the examples may be drawn from the physical world. Usability principles are the basis for heuristic evaluation. There is a long list of principles that we can check one by considering a whole interface and checking whether the whole interface is consistent, prevents errors, applies visibility, etc. I will now cover each of these principles very briefly, and we have a separate web lecture on each of them. The first principle is to make sure that the system status is always visible. So when the system is busy, for instance, you try to start an application and the system can't do that right away, it should show you this state. It should show you how long you sometimes have to wait. And when the system is waiting for input, it should give a visual sign that it is actually in that state. Whenever possible, interfaces should match the equivalent in the real world. This can be done, for instance, by using icons that correspond to physical objects, like, in this case, a trash can. But the match also deals with the process. For instance, if we want to move something on a physical desk or on the floor, it's similar to what we now do on the computer with drag and drop. We should give users control and freedom, but that's actually not entirely real. Right? Users should feel that they are in control. It's just a feeling that is enhanced by the do what I want principle. When we're driving a car, we're using the steering wheel, the accelerator, and the brake pedal, and we feel in control. Now, obviously, this isn't real. We aren't really in control. Consistency and standards is the same as the corresponding design principle, to follow standards if they exist, and if they don't exist, look at other applications that do exist and try to be consistent with them. Regarding errors, it's always best to prevent them from happening, but if we can't, we must handle them gracefully. Preventing errors can, for instance, be done by clearly highlighting the most likely control to be clicked, even though, in this case, the Mac OS order is different from the Windows order, which has the OK button on the left. Errors need to be handled gently, meaning that we should tell the user, first of all, what is really going wrong. And we should do that in terms that are meaningful for the user. We should also make it clear how to recover from the error. If something went wrong, how can we correct it? The existence of undo facilities are very important here. Flexibility and efficiency of use. For novice users, we have interface elements that are not always so efficient, like menus and toolbars. When we're typing something, it's much more efficient to use keyboard shortcuts. But those take longer to learn. So we should also offer support for the transition from beginning user to expert. Offering dummy modes often helps where complex and the most efficient ways of using tools are hidden. This transition we see, for instance, in a camera interface, where there are dummy modes, typically called the scene modes, and there are advanced modes that let you control shutter speed and aperture directly. Also, whenever possible, use parallel dialogue to offer the option to use menus or keyboard, to have dialog boxes that are non-modal so they can be used in parallel with the main interface. We are better at recalling something when we see it than just recalling it from memory. So to recall what we see, which is what we call recognition, visual cues can help. We are always better at recognizing than we are at remembering details. You can recognize a song that you hear, but if we give you the title, you could not sing it. The principle also applies with this common saying, if it looks like a duck, swims like a duck, quacks like a duck, it's probably a duck, and our interfaces should be like that. We should also try to make our interfaces aesthetic yet minimal. We see a move now from detailed graphical designs. If we look at the Mac OS dock with the most commonly used commands, it has sort of a pseudo 3D effect and very detailed icons. And the lower image is what we will be seeing in a new version of Mac OS with much simpler icons, a simpler design, which is easier to grasp, even though it's not that refined. We will also talk about help and documentation. And it's important to notice these are not the same. Documentation is written to learn how to use an interface or a device. It helps to offer documentation in digital form because then we can search, we can perhaps follow links, but it is detailed material for learning. Help, on the other hand, is used for troubleshooting. While you are using an application, when you are stuck, help is there to tell you what your options are. And because you ask for help, when you are in a specific context, the help can be made context sensitive. Help can take into account everything you did with the interface until the moment you are stuck. Now, at some point, you are going to do a final project. In this final project, it's a good idea to provide help, but you are also required to produce documentation. The documentation cannot be missing with the excuse that everything is written in the help. They serve a different purpose, and they must both be supplied. Thank you for participating.